Hi, everyone, and welcome to today's Safety and Health webcast, a proactive approach to weld fume management, how to assess, plan, and be prepared amid the new environment, sponsored by Miller. My name is Kevin Drewley. I'm an associate editor with Safety and Health magazine, and I will be moderating today's session. Thanks for joining us. We hope you all are safe and well amid the evolving COVID-19 pandemic. In a few minutes, we'll start the presentation, but first I want to go over some preliminary items. The views of today's speakers and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box in the lower left-hand corner of your screen and click the button for Submit Question. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speakers. For basic troubleshooting information, click the Help button located on your screen. At the end of the webcast, you'll be asked to complete a brief evaluation survey. I will let you know more about that after the presentation. Additionally, our sponsor has made available various resources to accompany today's presentation. You can find them under the Resources widget at the lower left-hand part of your screen. This webcast is archived so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our panel of speakers today features Bert Schiller, Susan Fiore, Jeremy Bruzewitz, and Kevin Quinn. Bert is an industrial hygienist certified in the comprehensive practice of industrial hygiene. He boasts more than 35 years of experience in various industries, including past work with Michigan OSHA. He has taught at the University of Michigan for the past 5 years. Susan is an advanced applications manager with Hobart Brothers Welding, with more than 30 years of experience in the welding industry. In her current role with Hobart, Susan works closely with customers to resolve issues and to promote new ideas and welding innovations. She's a fellow of the American Welding Society and serves as chair of the AWS Safety and Health Subcommittee on Fumes and Gases. Jeremy is a product specialist for the Welding Safety and Health team at Miller Electric Welding. Jeremy brings more than 7 years of experience with an emphasis on weld fume extraction. He works directly with engineers at Miller to identify end-user needs to develop fume extraction products to address those needs. Kevin is a Welding Safety Solutions Manager with Miller Electric Welding, with more than 12 years of experience in industrial safety, with a focus on respiratory protection. His role with Miller involves working with industrial customers to address welding fume issues to protect their workers and the environment. We thank you all for being here. Bert, whenever you're ready, go ahead and take it away.
Well, thank you very much and welcome, everyone. Let me first touch on a disclaimer here. Welding fumes and gases cannot be classified simply. The composition and quantity of both are dependent upon the metal being welded, the process, procedures, and electrodes used, the number of welders, the size of the welding area, and the ventilation impact the composition of welding fume and gases also. Accordingly, every welding environment is different and needs to be evaluated by a certified industrial hygienist to determine the appropriate course of action for future controls. Next slide, please. So we're going to talk about weld fume controls. We're going to discuss the factors that impact a welder's exposure. Some of those I already mentioned in the disclaimer. We're going to touch upon some of the recent regulatory issues surrounding welding fumes. And we're going to have a detailed discussion about the hierarchy of controls. There's several factors that impact operator exposures. Next slide. And those being the type of welding process, whether it be MIG, TIG, sub-arc, or stick welding. The process and procedures and the electrodes used, we're going to have a detailed discussion about the different welding electrodes. Obviously, the number of welding and how they're spaced. What's their environment like? Are they in an enclosed environment? Are they outdoors? The size of the welding area is extremely important. And then, of course, it's ventilation. We're going to talk about different hierarchy of controls later, including engineering controls, which would be general exhaust ventilation, as well as local exhaust ventilation systems. Next slide. We're going to talk both about the base metals and the filler metals used when welding. The base metals most commonly are mild steel, but you can also weld on stainless steel, galvanized steel, or aluminum. These all make a difference in the type of fume that's being generated. And then the filler metals of the electrodes are also extremely important, including nickel, copper, of course iron, but also others such as manganese, which we're going to talk about. Next slide. When we're talking about welding fumes, we want to talk about how much welding is being done. Not only how much, but how often. Is there a break? What type of welding? As I already mentioned, the different types of welding, including MIG, TIG, flux core welding, generate different amounts of fumes. What is the base metal you're welding on? Is it mild steel or stainless steel? A big difference, which we're going to talk about in a minute. Where is the welding being conducted? Is it a well-ventilated area? Is it restricted or in a confined space? These are all going to affect the amount and type of fume that's being generated. Where are there changes that impact your environment? A newly configured workspace or in a confined area can drastically affect the welding environment. Let's first talk about OSHA. Everyone knows about the permissible exposure limits for welding. About 7 years ago, OSHA came out with their first new standard in terms of industrial hygiene in quite a while, and that had to do with hexavalent chromium. The hexavalent chromium standard actually touches on two distinct different processes. Plating operations using chromic acid, but it also covers welding on stainless steel. Stainless steel contains chromium in its natural or trivalent state, +3. When you heat chromium-3 up to high temperatures, such as when welding, it changes into chromium +6, otherwise known as hexavalent chromium. Hexavalent chromium is extremely corrosive and can affect lung tissue. That's why the standard was developed, and you'll see on the slide it has relatively low exposure limits of 5 micrograms per cubic meter as a permissible limit, and OSHA has also established an action level of 2.5 micrograms per cubic meter. If a welder is exposed above the PEL, there's requirements in the standard for quarterly monitoring, medical surveillance, respiratory protection, and other features. One of the other common metals that's encountered during welding is manganese. Manganese is not in the base metal. Manganese is typically found in the welding electrode. The current OSHA PEL for manganese is relatively high, 5 micrograms per, or milligrams per cubic meter, milligrams. This is a ceiling limit, which means it's never supposed to be exceeded. Quite often, however, the OSHA PELs are rather outdated. The more up-to-date limits reflecting current scientific thought are the threshold limit values developed by the ACGIH, the American Conference of Governmental Industrial Hygienists. This is an NGO, a non-governmental agency. It predates OSHA by some 20 years, and they've been establishing exposure limits. They were really the first organization anywhere in the world to develop these exposure limits. And actually many countries, including Italy, closely follow the recommendations set by this non-governmental agency. You'll see the two compounds I just talked about, hexavalent chromium, which is given off from stainless steel base metal. They've established a relatively low exposure limit, as you can see on the chart, well below the OSHA permissible exposure limit. Likewise, manganese has a much lower exposure limit, 0.02 milligrams per cubic meter. This is some 250 times lower than the OSHA PEL. It's always considered good practice to try and reduce exposures not only below the OSHA limits, but below the threshold limit values, which again are the most current thinking. So if you want to have an assessment done, it's best to have a qualified safety and health professional assess your facility. Ideally, you should use a certified industrial hygienist. The American Board of Industrial Hygiene, ABIH, provides a certification examination for industrial hygienists to achieve this status. If you can't have a certified industrial hygienist do your survey, at least have an established safety and health professional who's working directly under the supervision of a CIH. Where do you find a CIH? There may be one on your corporate staff. Your insurance broker or underwriter might have one. And actually, some OSHA state programs have consultation groups which provide these services outside of the regulatory enforcement mechanism. And lastly, of course, there are consultants that provide these services. I believe now we're going to have a poll question, correct?
Yes, Bert, that's correct. Thank you. What you're seeing now, folks, is the first of two poll questions we've got for you today. We're asking now, when was air monitoring for weld fume last conducted at your workplace? The choices we have are 0 to 12 months, 12 to 24 months, uncertain, or NA. We'll give you about 30 seconds to respond, and then we'll go ahead and review the answers. About 10 more seconds if you've not yet responded. Okay, let's go ahead and look at the results. So close race. We either had NA was the leader at 35%, followed by uncertain at 34.5%, followed by 0 to 12 months at 19%, and 12 to 24 months at 11.5%. So again, thank you for participating, and there will be one more poll question closer to the end of the presentation today.
I think the ball's back in my court. This is Bert Schiller again. Let me make a comment on this. I was told once by a workers' comp attorney that any data, such as data on welding fume exposures older than 2 or 3 years at the most, is pretty much outdated. So it's always advisable to keep your industrial hygiene exposure data current, meaning no older than 2 or 3 years at the most. If you get into a workers' comp situation, you have to have current data. Next, we're going to talk about the OSHA Hierarchy of Controls, which is a classic control strategy. You see the pyramid here. At the top, you will see engineering controls, substitution of a less toxic material for a more toxic one. Then we have engineering controls, work practice controls, and bottom, last but not least, is personal protective equipment. Here to talk more of you about engineering controls, I'm going to hand it off to Susan. Susan?
I'm sorry, I think I was on mute. I apologize for that. As many of these as I've done, I think I would have known that by now. So again, this is Susan Fiore, and I'm going to be talking about process modification and substitution. Process modification and substitution is the first step in the hierarchy of controls. It is also the most effective, since it removes or reduces the danger to the environment, thereby protecting not only the welder, but also those workers in the surrounding area. The first option for this process modification is to eliminate welding. But since this is a welding safety presentation, I'm not going to get into that. Other options include modifying the welding process, which could include changes to the process itself, as well as changes to the welding parameters. Automation is another process modification that can help reduce exposure to welding fumes. Changes to the materials, including changes to the filler metals, the shielding gas, and the base material, are another way to reduce fume exposures. Keep in mind that these sorts of changes may require you to requalify your welding procedures. This slide shows how changing the welding processes, and in some cases the shielding gas, can help to reduce the amount of fume that is generated. Processes such as gas tungsten arc welding and submerged arc welding tend to be very low in fumes. Unfortunately, gas tungsten arc welding is also very low deposition and requires a high degree of welder skill. Submerged arc welding, on the other hand, can only be used in the flat and horizontal position and may require a large investment in equipment. Solid wire gas metal arc welding tends to be relatively low fuming, especially if pulse transfer is used with high argon shielding gas mixtures. I'll talk a little bit more about that later on. There are a variety of flux and metal cord welding products, some of which are designed specifically to be low fuming, and others that may target specific elements in the fume, such as manganese or hexavalent chromium. This slide shows the effect of shielding gas on fume generation rate for gas metal arc welding. The results are similar for flux cord arc welding. The bottom line is that the less active the shielding gas is, that is, the higher the argon content, the lower the fume generation rate will be. Another option is to choose a filler metal that targets specific constituents in the welding fume. This graphic gives a comparison of manganese exposure using a low manganese flux cord wire versus a traditional flux cord wire. Reductions in manganese exposures of 50% or more are possible with these low manganese filler wires. You should note that the testing shown here was done in our test lab under controlled conditions. You should always do exposure testing in your own facility to verify results due to the large number of variables that can affect fume exposures. As Bert mentioned earlier, some of these variables include things like the specific welders and how they position themselves relative to the fume plume, the welding parameters, the room dimensions, local exhaust ventilation, the number of welding operations, etc. As I mentioned earlier, the type of weld metal transfer can have a significant impact on fume generation. Modified short-circuiting transfer provides a more stable arc than conventional short-circuiting transfer, which can help to reduce fumes. It has also been found that switching from conventional spray transfer to pulse transfer when gas metal arc welding can significantly reduce welding fume generation. Keep in mind, though, that a simple change to pulse may not result in the expected decrease in fume generation. You may need to optimize the welding parameters to get the desired results. You should contact your welding supplier if you need assistance. Also note that we do not typically see a similar reduction in fume when we use pulse transfer with flux and metal cord wires. In summary, there are many advantages to lowering welding fume generation by modifying or changing the welding process. The greatest being that it helps to protect the welder as well as those workers in the surrounding area. It can also be a way to target specific fume constituents such as manganese. And finally, these types of changes are generally relatively simple to implement. Some of the disadvantages of modifying the welding process include the possible need to invest in new equipment, as well as the need for additional training or requalification. You should also keep in mind that not all processes will work in all situations. Things to consider include the deposition rate, positional capabilities, and mechanical property requirements. Finally, if you're considering changing shielding gas, keep in mind that argon-based gas mixtures are typically more expensive than CO2. I will now turn the presentation over to Jeremy, who will be talking about the next tier on the hierarchy of controls, which is the engineering controls. Jeremy?
Thanks, Stu. So I'm here to talk to you guys about the second most effective level of control recommended by OSHA. And this is engineering controls, which is basically creating a barrier between the weld operator and the hazard. They're really broken into three types: local exhaust, process enclosure, and general ventilation. Local exhaust, or source capture, removes the fume at the source before it reaches the operator's breathing zone. This can be done by extraction arms, backdraft hoods, downdraft tables, or fume guns. Process enclosures is basically creating a barrier between the operator and the process, mainly in automation hoods or automation cells. General ventilation, HVAC, is moving large quantities of air to dilute and filter by an air exchange rate. I want to talk a little bit about fume guns. Capturing fume generated by the welding process right at the source. This is one of the best ways of capturing weld fume because it is at the source and the welder was always moving the gun into position. It is tailored to best meet the specific application or welder preferences. This is ideal for tight and confined spaces or if there is multiple welds on a large part. Some of the best practices with fume gun is the positioning of the fume gun over the weld puddle, making sure that you have that 90-degree angle to capture the fume. Pausing at the end of each weld is good to make sure you capture all that fume that is after the welding process is being completed. Frequently inspect the front of the gun for damage or buildup that could affect the capture at the tip. Routinely inspect the vacuum hose for any cuts or tears that negatively could impact the flow of the fume gun. Some other items about the fume gun normally are between 300 and 600 amps, and the higher the amp gun, typically it means that there's a little bit more weight to them. But that's not why you should pick the gun. The gun should be designed around the correct amperage and duty cycle rating when purchasing. Some other features to think about when purchasing fume guns would be an adjustable vacuum chamber. The chamber allows for better joint access and visibility of the puddle. Another item would be suction control valve. This will help balance the suction so it does not affect the shielding gas that would create porosity in the weld. Flexible and snag-resistant hoses are also important to increase flexibility while moving around in the facility. You also do not want, it doesn't allow you to have to add an additional hose cover to add weight. Handle and neck options are also tailored to the welder's preference. This will improve weld access to the weld, as well as fatigue on the welder. Another thing to look at is consumables. You want to make sure that the standard parts are the same as the MIG guns that you're using elsewhere, such as nozzles and tips. Now I want to get into some other source capture devices. They're really around portable, mobile, stationary, and centralized. Portable is more for maintenance and repair, light duty, easy to move around your shop and get into tight areas. Typically, it is used with a small vacuum hose that's designed for weld fume. This is able to get in those, like I said, those tight areas, normally with other attachments such as flex nozzles or fume guns. Mobile is more for heavier welding in open bays or open floor. This is good for moving around your shop or going into multiple stations in your facility. This gives you the flexibility to move it around and capture weld fume. If you do not have the floor space in your facility, you may want to look at stationary units. These can be mounted on a pedestal, wall, or ceiling, and is ideal when you do not have the floor space. Typically can be 1 to 2 suction arms on these systems. If you're looking at multiple stations for heavy welding and you do not have the floor space as well, and you may want to look at a centralized system. You can run ductwork to each cell to hook up to arms or hoods, and typically these units are placed indoors or outdoors. General ventilation. These systems are effective in moving large quantities of air or dilute and filter the base like before I mentioned. This works for cleaning up the entire shop, but does not collect the weld at the source. That means you may need to look into other means to protect the welder. These are also known as ambient systems or push-pull. Process enclosure is a great way of capturing weld fume. Typically, it is using a hood to stop the fume from migrating into other areas of the shop. These can be put over automation cells or blocking off an area inside your facility with weld curtains as well. When looking at fume extraction, you want to look at each location individually, and that's not just an entire shop, it's each welder individually. There's many factors that can play into a welder's fume extraction. One being work environment. Doors or fans can affect the fume travel. You want to make sure that you're placing the equipment in the proper position, that you're capturing the weld fume before it passes the breathing zone of the welder. Weld joint and size. You may, depending on the size of the joint, you may need to position the capturer's arm in multiple positions, or consider the mobility of the welder. If he's moving around the shop, he may need a mobile cart, or if he's over a workbench, then you can look at more of a stationary position. It really depends on how the welder moves in his area. Other equipment, such as cranes or other elements in manufacturing process, can limit the type of fume extraction that is used. So when looking at facilities, we want to make sure that we're capturing everything in that would affect the weld capture. Another item to consider when looking at fume extraction is what type of filters are in the unit. Typically, there's 2 types of filters that we're going to talk about today. One being the disposable filter, and then the self-cleaning unit. What this is for disposable filters are mainly used for light applications, low on-arc time, where you're not doing a lot of welding. Self-cleaning filters are more for heavy applications, and you may get up to 8 times the life out of the filter by using a self-cleaning. Now, it's not the filter that is different, it's actually the unit itself that has changed. With the self-cleaning unit, there's normally compressed air that's hooked up to the machine that will knock off the larger particulate into a dustbin below, and then the dustbin is taken care of. Normally, we recommend anything that's 8-hour shift or above, you would go with self-cleaning because the payback is with the filter media. Some other items that may affect the filter is quantity of fume, type of fume, cleanliness of part, hours of operation, and cleaning cycles. And what I mean by this is more, TIG is different than MIG welding versus stick welding. There is more fume generated during stick welding, more particulate than there would be during TIG. It also depends on the mild steel, or if you're welding mild steel or stainless. All items come into play when you're looking at filter types and quantity of filter. Another large item that will affect the filter life is the moisture contact. Oils, anti-spatter, rust inhibitors, or high humidity will affect the filters and can affect it up to 50% depending on the type of oil or type of moisture that is put into the extraction. So now I want to review the engineering controls advantages and disadvantages. Some advantages is capturing the weld fume before it reaches the operator. That is key, making sure that the operator is safe from the particulate getting to them. Improve workplace environment. With a shortage in welders, having a clean shop is key to bringing in new employees. Solutions for almost every application. This is breaking down each location and shop, making sure that you have the right material, and if you can get engineering controls in there, that is one of the best ways of doing it. Next would be new technology continues to come out, especially increasing the weld fume capture zone, such as zone flow technology. Some keys to consider. Space constraints. You may have to make physical changes to your facility. If you're looking at centralized systems, you may need to add ductwork or place the collector indoors or outdoors, mounting stationary systems on the wall. You may need to make other changes, bring in compressed air to the machines. So that's something to take a look at. Also, productivity can be affected when you're talking about arm interactions. That's one of the things that you can look at is larger capture zone to mitigate that, but you want to make sure that the arm is positioned correctly to capture the weld fume. So if they're doing multiple welds, they need to position the arm properly. Another item would be consumable cost. The main item would be the filters. That's why it's key to make sure you're getting the correct filter and correct unit for your facility. Now I want to walk you through the third stage of the OSHA hierarchy of controls, and that's work practice controls. Now this does not remove the hazard, but it's mainly about positioning and setting the operator up so it can limit or prevent exposure. One of the main items is body positioning, keeping the head and body out of the fumes to limit the exposure to the welder. This also will increase his visibility to perform his job. So making sure that he has the clear visual of the puddle is key to keeping the exposure down. Proper training, can reduce the spatter fume generation, overwelding, or even cleanup or rework. If they're properly trained on the pieces that they're welding on, this can limit the amount of welding they're doing, which will then end up saving money in the long run. And the key consideration is training is the essential for a successful workshop, making sure that all employees are trained properly around the welding process. So some advantages and key considerations to the work practice controls. Proper welding technique can lead to less scrap and rework. Enhanced visibility of the operator can lead to higher productivity rates. Some key considerations. Training devices are investments, but can save in the long run with less scrap and higher productivity, like the advantages that we just talked about. Requires a behavior change in the work or weld environment. Welder acceptance is key to a successful workshop. Making sure your welders are happy and have the proper equipment is key to make them happy. Now I'll turn it over to Kevin, who will talk about the personal protective equipment.
Thank you, Jeremy. Good afternoon, everybody. We are now going to dive into the fourth tier on OSHA's hierarchy of controls, which is PPE, or specifically in this case, respirators. Please keep in mind that the fourth tier for the hierarchy should only be used after all other methods of controls that we've already discussed have been explored. Many times PPE will be used in addition to, not in place of, other methods of control. However, there are times where respirators can be used first. They include maintenance and repair operations, emergency operations, and also during the installation of engineer controls. Respirators are very personal safety item because they are designed to create a physical barrier between the operator and the hazard. It's very important to get it right when it comes to a workplace respiratory program. The importance of the respiratory program cannot be stressed enough. When you decide to implement a program, there are things you will want to do to make sure your workers are safe and to ensure all record keeping is complete and accurate. The details of a written respiratory plan can be found in OSHA's 29 CFR 1910.134. This is a great guide. It will offer a lot of different resources and a lot of how-tos to get a program up and running. OSHA states a respirator shall be provided to each employee when such equipment is necessary to protect the health of such employee. The employer shall provide the respirators which are applicable and suitable for the purpose that was intended. What that basically means is that you give the correct type of filtration unit, the correct type of mask for the work that your people are going to be doing. The employer shall be responsible for the establishment and maintenance of a written respiratory program for each employee that will use a respirator. The written program can appear intimidating, but it is really straightforward once you understand it. So let's dive a little bit more into the details. There are two uses of respirators within a facility, the first being mandatory and the second being voluntary. Once a mandatory respiratory program is instituted, your program must include the following: written worksite specific procedures, so instructions for when, where, and how to use the respirators. A program evaluation. This program should be evaluated frequently and updated to include any changes in the workplace, such as changes in procedures, base metals, filler metals, etc. Selection of an appropriate respirator approved by NIOSH. This is determined by evaluating the hazard and its extent. Please always make sure that the respirator you employ is a currently certified NIOSH respirator. Training. Training should be completed by a competent, trained professional. Fit testing. This is required for all tight-fitting respirators. This will require the users to be clean-shaven at all times during respiratory use. Inspection, cleaning, maintenance, and storage. This is, of course, a responsibility of the company as they provide the products. Medical evaluations. This is meant to examine the medical fitness of the workers to work in the areas where the respirators are required. This could usually be conducted with a questionnaire that is found in the standard itself, and then possibly followed up with a physical examination by a medical professional. Work area surveillance. And then finally, air quality standards, checking the exposure to ensure you remain below the OSHA PELs. The voluntary program isn't as stringent as mandatory. However, there are still steps that must be followed. This is applicable if you offer voluntary respirators or even if the employee provides their own. All right. Please keep in mind that this does not apply to things that we're seeing every day right now with COVID, such as dust masks or just general face masks. But you still need to conduct the medical evaluations. You still need to provide the ability to maintain and care for the respirators. And you also still need to make sure you follow the OSHA certifications for 29 CFR 1910-134. Okay, so now I'd like to go over some of the acronyms and terms that we just threw out there and that you will hear frequently when you go into a respiratory program. The first is Assigned Protection Factor, or APF. This is the level of protection that a respirator or class of respirators is expected to provide according to the design. Examples of this: APF of 10 for a half mask respirator, 50 for a full face piece, and 25 or 1,000 for a loose-fitting powered air purifying respirator. The larger the number, the greater the protection it provides to the user. As an example of of this, what is properly used as respirator, with a protection factor of 10 will reduce the exposure by 1/10 of the concentration, or to 1/10 of the concentration. The next is maximum use concentration, or MUC. This is the maximum concentration of a hazardous substance that an employee can be exposed to. The way these two terms tie together is to take the APF of your respirator and multiply it by OSHA's PEL for your hazard. This will give you the MUC. By using air sampling to test your actual environment, you will know if your protection keeps you underneath of the MUC. Here are some examples of air purifying respirators that we're discussing. Despite the differences in methods or designs, these all accomplish the same goal of filtering out contaminants before the user breathes them via a filter material. The first would be the most basic, which is a disposable dust mask. These are paper-like, and they are a tight-fitting respirator. They offer an APF of 10. The next step is a reusable cartridge-style half-mask respirator. These utilize a replaceable filter and a more substantial, tight-fitting mask. Again, these offer an APF of 10. They both also do require fit testing. A different approach to the tight-fitting respirator is a powered air purifying respirator. This system is not tight-fitting. It uses a loose-fitting, positive pressure system. As a result, fit testing is not required. These systems provide the filtered air rather than the user pulling the air through the filter by breathing. These also can offer a higher protection factor, starting at either 25 or up to 1,000. The next type of system that we'll talk about is an atmospheric supplying respirator. This system provides the user with grade D breathing air from a source outside of the work area. This is accomplished with an air line that is filtered and monitored for CO. These systems have the benefit of offering air conditioning to provide comfort to the users. These also offer the same level of protection as a PAPR, which is either 25 or 1,000. Within the respiratory category, there are two classifications we've talked about already. The first is tight fitting. This system has a face covering that forms a complete seal with the face. The seal is the reason that we constantly we're frequently fighting with our employees to make sure that they are clean shaven. If you do have a full beard or even day-old stubble, it can compromise that seal. These systems require fit testing, and there are two different ways to accomplish this. The first is qualitative. It's a pass-fail test where a smell or irritant is introduced to test leakage of the seal. Quantitative testing utilizes a probe and a machine to test the mask's effectiveness. Loose-fitting systems form a partial seal with the face and rely on positive air pressure from a supplied air system or a PAPR. These systems are nice because they do not require fit testing and they do allow a reasonable amount of facial hair. So some advantages of each of the different types. When you're looking at both of the PAPRs and the supplied air, they delivered filtered breathing air to the user's breathing zone. This can make a big difference. I think during COVID, we've all had to wear masks at some point or for long periods of time. And it does take a toll on your body if you're wearing it for long periods of time, especially when it's a hot work environment. So it can be much more comfortable. It can be much easier on the user. With the supplied air systems, it does provide heat stress relief. So cooling the air up to 50 degrees can be very, very nice when it's July and August. It also combats safety glasses and helmet lens fogging. By supplying the air inside of the helmet and circulating it, it can keep the glasses from fogging up, which also helps with different safety concerns. Some key considerations when we're looking at these type of systems, they should be considered the last need of protection according to OSHA. So you should still look at the other three steps that we discussed earlier before you go to PPE. You do need to create a written respiratory program if you do if you allow them in your facility. There is, of course, always going to be a consumable cost for the filters and for the systems. And it can place a burden on the employee. I mentioned how it's a very personal item. Some people adhere to it, they go to it right away. Other people aren't very comfortable, so it's definitely something you have to take into consideration. At this point, I believe I'm going to pass it back to Bert so he can go through, summarize our discussion, and jump into, I believe, a poll at this point.
Yes, we do have one more poll, not trying to intercept Bert, but yeah, have got that one more poll question as promised. So this one we're asking, what is the main reason for possibly not implementing better weld fume protection solutions in your welding environment? And the choices are not benchmarking current concentration and exposure levels, knowledge of proper mitigation approach, investment in equipment cost, ability to justify ROI, or NA. As before, we'll give you about 30 seconds to answer this one. Okay. 10 more seconds to respond if you haven't already. Okay, have another close one, not as close as last one, but the leading response was investment in equipment cost at 22.5%. Oh, I'm sorry, NA again was a leader. That was 37.1. But among those who have these reasons cited, investment in equipment cost was the leader, followed by not benchmarking current concentration and exposure levels. We then had knowledge of proper mitigation approach and ability to justify ROI. And with that, we will get it back to Bert.
Well, thank you very much. Just a comment on that slide, and again, an industrial hygienist or a qualified safety professional could help answer both of those first two questions. You'd be able to benchmark what your current exposure levels are, and that individual might be able to help you come up with the proper mitigation approach. So in the OSHA hierarchy of controls, sometimes it may take more than one control measure. You may have to use multiple solutions to solve a problem. For example, the exposure limit for manganese is very low. You might need to use a low manganese electrode, for example, which has been discussed, in addition to local exhaust ventilation. So that would be an example of substitution and engineering controls. In extreme cases, say you're welding on stainless steel in a confined environment, you might have to use local exhaust ventilation and still use respiratory protection. Again, it's going to require testing and maybe retesting. Again, if it's hexavalent chromium and you're over the exposure limit, you have to do quarterly monitoring. If you're above the action level, 1/2 of the PEL, you have to do monitoring every 6 months. So really it's an ongoing process with periodic monitoring. As I said earlier in the presentation, at a minimum, these exposures should be documented and kept on file. You should have updated information at a minimum every 3 years. So in summary, if you still feel this is too complicated, reach out for assistance from an insurance company, state or local OSHA programs, industrial hygiene consultants. The benefits of controlling your air quality, not only are you providing comfort and increased productivity on the part of your worker, you're going to reduce indirect costs. Remember workers' compensation. You're going to keep OSHA out of your building. I've been involved with many cases where complaints have been filed with OSHA. OSHA will call the company and ask if any recent testing has been done. If the company is able to provide documentation that recent testing was done, OSHA will not come into the facility. And last but not least, it can help to recruit good workers, which is always a plus. So with that, I'm going to turn it back over to Kevin, the moderator, and I believe we have some time left for questions.
Yes, no, excellent. Great job, Bert, and great job, everyone. Thanks for your insights and expertise. Before we do start the Q&A, just want to remind everyone of the evaluation survey that we're asking you to complete. The survey should be appearing on your screen now. Your input is important because it will help us improve future webcasts. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. And now we will get to some questions. First, and this one is for Jeremy. How do you know what type of fume extractor is best for your facility?
That is one of those things you want to evaluate each location and make sure, and not just location as a shop, but you want to look at each welder individually to make sure that they have the right piece of equipment in your facility.
Okay, next one is for Bert. Is there any chance that OSHA may consider lowering the manganese PEL at any time in the foreseeable future?
The short answer is no. I'm not aware of any movement to lower that standard. I'll just leave it at that. No.
Okay. Thank you. Now we have a question for Susan. Why are the fume generation rates for gas tungsten arc welding and submerged arc welding so much lower than they are for other welding processes?
Well, it's fairly simple. For gas tungsten arc welding, it's a very, like I said before, it's a very low deposition process, and typically it's done under argon shielding. So there's really not much oxidation that's occurring, and so the fume generation rates tend to be low. For submerged arc welding, the flux that you use actually blankets the weld and helps to capture the fume, so it doesn't escape into the surrounding atmosphere.
Next one comes in for Kevin. Why don't PAPRs require fit testing?
PAPRs don't require fit testing because they don't have a tight-fitting face seal like a half mask would. So there is no fit testing for that type of a setup.
All right, circling back to the top of the order, so to speak, we've got one for Jeremy. How much noise does the extraction device generate?
Each extraction device is completely different. I can tell you, like with ours, we're right around that 75 decibels. But depending on, each extraction device could be different.
Bert, this one's for you. Are there real-time instruments that can provide exposure limits? And if so, could you please identify?
Well, that's an excellent question. There's no real-time instrumentation that can identify particular metals. In other words, you can't identify manganese or iron oxide in real time. There are real-time optical scanning devices which can give you total weld fume concentrations in real time. So you could determine milligrams per cubic meter of total weld fume, which would certainly be helpful in diagnosing if you have a potential problem. So qualified, yes.
All right. For Susan, this one asks, how does GMAW with ER5356 and ER4043 compare to ER705-6?
I'm going to have to look up some of the data on that. And, I'm basically, I don't know the answer to that one right off the top of my head, but I can get you the answer to that.
Okay. Well, no, we appreciate that, and I know the questioner will as well. We'll send this one to Kevin. So, is there any benefit to having a half mask over a dusk mask if the APF is the same?
No, there wouldn't be any additional benefit, and that's not something that I would recommend because you are likely going to compromise the seal of the half face mask by putting it over top of another one, and it could also be very difficult to breathe through if you were to do that.
For Jeremy, will fume collection system accumulate static electricity and require equipment grounding?
I can kind of refer to ours. Ours, when you're capturing weld fume, it does not collect static, and it does not need grounding on ours. I can't really specify for other pieces of equipment, though.
For Bert, this one asks, how do I evaluate if the filter in my mobile filtration unit is actually meeting the needs of my shop?
Well, you'd have to refer to the particular instruction manual for the filtration device. It should give you an indication on the frequency when it needs to be changed. Also, a visual inspection of the filter should tell you when it's time to change.
For Susan, this one is a follow-up a little bit to something you had dealt with moments ago, but it just looking for a confirmation that weld fume generation is greatly affected by current, correct?
Yes, it is, but it's not necessarily a simple relationship. It has a lot to do with the stability of the arc, but yeah, so it's generally, as the current increases, you will see higher fume generation, but it's not a linear relationship.
For Jeremy, this one asks, can you use a mobile fume extractor with a fume gun, or is there a specific fume system?
It's more of a specific fume system. You would be looking at more of a high-vac type system, but high-vac systems can come in mobile or stationary, depending on what piece of equipment you're looking at.
All right, this one now for Bert. If you need to perform air monitoring for welding fume, where do you suggest sampling? Would it be inside the welding helmet or outside the helmet?
Excellent question again. Inside the helmet. The OSHA technical manual, which is their instruction to their people, mandates that you sample underneath the hood. The exception is if it's a tight-fitting respirator or PAPR. You don't want to put it under the PAPR, but if it's a standard welding hood, put it by the chin.
All right. This one now for Jeremy again. What's the minimum CFM for a portable fume extractor?
That really depends on the size of the capture device. Typically what you're looking for is about 2,000 feet per minute to move weld fume inside the arm. So like with our 8-inch arms, we do 1,200 CFM. 6-inch arms, we're around 600 CFM. So it really depends on the size of the arm, but you want to make sure you have a minimum by ACIGH is a minimum of 2,000 feet per minute.
Going back to Bert, this one, Bert was just looking for a clarification. It states that in one of the slides I saw, the ACGIH manganese limit was noted as, quote, total particulate, unquote. Shouldn't it be respiratory particulate matter? And again, just was asking you to speak to this.
ACGIH has a limit for both total particulate and respirable particulate. I believe the respirable is half of the total particulate limit. So you could sample either way. Most of the other metals will be sampled as total particulate, even though weld fume, 70% of weld fume is respirable.
For Jeremy, this asks, is there a form of spark arrestor in the system to prevent fires in the hoses or in the fume equipment?
Yeah, we try to put spark arrestors in all of our equipment. For our centralized systems, it would be in the ductwork, and then for our mobile and items like that, we try to put it into our devices. I can't speak, like I said, I can't speak for other equipment, but yeah, for ours, we do put spark arrestors in it.
Well, thank you. Unfortunately, we have run out of time today. I'm sorry we didn't get to everyone's questions, but all of today's unanswered questions will be forwarded on to our speakers. Once again, we hope you take the time to fill out the evaluation survey on your screen and give us your feedback. With that, we end today's Safety and Health Magazine webcast. would like to thank Bert Schiller, Susan Fiore, Jeremy Brusewitz, Kevin Quinn, everyone at Miller, and all of you who listened in today. Thanks and have a great day.